So welcome to my new video. So in this video, I will talk about B tree deletion and deletion operation in B tree. So in the last video, we saw about the introduction about B tree, how to construct a B tree. So in the last video, I told that the B tree is constructed using bottom-up approach. So why we need to what is the need for that bottom-up approach? So all other tree data structures are constructed using top-down approach, but why this B tree, especially this B tree, is constructed using bottom-up approach means so in the last video I told that one of the property of B tree is the balance property. So balance property means all the leaf nodes would be in the same level. So in order to maintain that balancing property, so we are on that we construct that B tree from the leaf level. So that is the main reason to maintain the balance property. The B tree construction is that bottom up approach is used for constructing a B tree. Okay. So in this video, B tree deletion means deleting a key from a B tree. So there are two cases for this deletion operation. So first one is the key which is to be deleted is in the leaf node. So there is we are going to delete a key from the leaf node, and one more case is the key for deleting a key from the internal node. So this video I will explain about delete a key from a leaf node. So just recall that so the property of B tree means suppose if the B tree is a M order B tree. So this means each node may contains M minus 1 keys. So and then the minimum key that each node should contain is M by 2 minus 1 key. Suppose if M equal to 5, then each key apart from the root node, each node should contain at least 5 by 2 minus 1 is equal to, so 5 by 2 is when you take seal this will be 3 minus 1 is 2. Okay, so this particular property you should remember. So according to this property, this particular case we may, so while deleting a key from the leaf node, so in that also we may encounter two cases. So first one is, so node have more than, so M by 2 minus 1 keys. This is the first case. And second one is node have exactly M by 2 minus 1 keys. So when you try to delete a key from leaf node, so there are two cases. We are going to delete that key from a node which contain more than M by 2 minus 1 keys, and the node which contain exactly m by 2 minus 1 keys. So first we will see with an example how to delete a key from a leaf node that contains more than m by 2 minus 1 key. Suppose take one example. Suppose I have a B tree. So suppose the B tree is, this is the B tree. Sorry. So just I'm just, this is a part of a B tree. So this is what this 50, 60, 70. That node is one internal node, and all these three nodes are the leaf node. Okay, now I am going to demonstrate how to delete a key from the leaf node, so which contains more than m by 2 minus 1 keys. Suppose, so take this example, m value is 5. So if m value is 5 means the minimum key needed in each node is 2. So in this we have 3 leaf node. In this 3 leaf node, all the leaf node contains 3 keys, but the minimum key needed is only 2. So if you need to delete any key, for example, if you need to delete a key 54, then just need to check from that root node we traverse where that 54 is actually placed. So start from the root node, we will reach this internal node 50, 60, 70. That internal node we will reach. So and then from that we will reach this particular node, and we check this node is a leaf node or not. So this node is a leaf node. So and then we will check whether this leaf node contains more than m by 2 minus 1 keys. So here m value is 2, m value is 5, so the minimum value needed is 2, but this node contains 3 keys. So we can just delete that particular node 54 from this. So after deleting, we check whether that B tree property is maintained. Yes. So in this node, still it contains 2 keys. So which is the minimum required number of keys in this 5 order B tree. Okay, so this is the first case. Now we will move to this is simple. So now we will move to the second case where we are going to delete a key which, so from a node which contain exactly m by 2 keys. So now take the same tree. Now I am trying to delete a node, delete a key 56. Okay. So from the root node I search for the key 56, and then finally I reach this leaf node, and once I reach the leaf node I will check the number of keys in that particular node. So since this is a M order B tree, the constraint is it should contains two keys. So if I delete this 56 from this node, then it will violate that particular constraint. So I cannot simply delete this node. So what I need to do is, so in this case we can follow two approaches. Okay, so two approaches means simply what we are going to do means we are going to get one node from the sibling, any one of the sibling. So each node can have two siblings, one left sibling and then right sibling. So in this case, after deletion, if the minimum number of keys constraint is violated, then we need to get a key from one of its sibling. So here we have two choices. So first one is get key from left sibling, and second one is the same, get key from right sibling. Okay, so first I will explain this first case, get sibling from the get key from the left sibling. So in this case I need to delete the key value 56 and I am getting a value from the left sibling. So in this while you getting a value from the left sibling, so we need to select the maximum value. So here the maximum value is 40. Okay, so and now I am deleting this particular key 56. So if I simply swap that 40 with the 56, so now if you swap that 40 with the 56, I just delete this 56 and 40 will come here. So and then that 40 we need to remove it from there. So actually this 40 will become first key in this node. That means 40 and 53. So after swapping, so I just select a max value and then I perform a swap operation. Okay, so if I simply perform this swap operation, now that basic property, that searching property. So I already told you this B tree is a kind of searching tree, like a binary search tree. So this particular node is pointed by the pointer that is placed between the first two values of its parent. So these values, keys of this node should be the values in between 50 and 60. But if you place 40 here, then that particular constraint is violated. So how to rectify this means just select the separator. So we have two separator here, 50 and 60. So in this case we need to select a separator which is minimum. So select min separator. So here this is 50. Okay, So and then just again swap. So now we need to swap this 50 and 40. So after swapping, so now 40 will go here and 50 will be placed here. Okay, so now all the properties like the minimum keys in each node and then that search property. So 40 and 60, so these two values 20 and 30 are less than 40, and 50 and 53 are in between 40 and 60. So now all these properties are maintained. So this is, so at simply what I am doing means I select a minimum value 40 from this, and then that separator 50 from this, and I just swap that separator 50 to the place of the deleted key. So and then the maximum value in the left subtree is placed in the parent. Okay, so just select a maximum value from the left subtree. So and then place that maximum value in the parent, and then the value that is stored in the parent, so place that parent value into the place of the deleted key. Or otherwise, those for your understanding, just select a maximum value from the left subtree and then swap that maximum value with the deleted value. So after that, select that minimum separator from the parent and swap that minimum separator with this maximum value. That is, this is the first case. So if we select value from the left child. So next I will explain the second case, how, so the same thing, so can be done by selecting a key from the right subtree also. Suppose we have in this left subtree we have 20 30. So yes, just for your understanding purpose I am adding another key value, that is 36. Okay, so now I need to delete the key value 53. So from the root node I just search for that 53 key, and then I will reach that key in the particular node which is a leaf node, and I try to delete that node. While deleting, it will violate that minimum key constraint, so I cannot able to simply delete the value. So now I can swap a value from the left subtree. So I go and check the left subtree I can able to swap it. Now, so how to swap it means just take a maximum value, that maximum value is 36, and swap that maximum value with the parent separator. So here the parent separator is 40. So 36 will placed in the place of 40, and then 40 will be moved to the place of 53. So this is left sibling, swapping with left sibling. So same thing we can also perform by using swap with right sibling. So how to perform this swap with the right sibling means so very similar to that swap with the left sibling. So here select minimum value. So here the minimum value is 62. 2 and then swap it. So just I'm going to delete this 62 from here, and then I'm swapping that 62 with 53. So but now also, so that searching property, so those 50 and 62 should be less than 60. That means it should be greater than 40 and less than 60, but 62 is greater than 60. So what we are going to do, just swap this 60 and 62. So 62 will go there and 60 will be placed here. And then means in this case, after performing the first swap, select maximum separator. Okay, so select the maximum separator. So in this left subtree, we select the minimum separator and then select maximum separator and swap it. So while you swap using right subtree, so we need to select a minimum value from the right subtree, and then we just delete that key and then swap that minimum value to the so replace that deleted key with the selected minimum value. So once you perform this swap, and then next we need to select the maximum separator in the parent, and we need to swap that maximum separator with the new value. Okay, so this is the way we can able to delete a key. So with from the leaf node which exactly contains m by 2 minus 1 key. So in this we saw about two cases. One case is getting a value from the left sibling, and another one is getting a value from the right sibling. So when you look on this particular example, you can understand that while swapping that values, so both the left subtree and the right subtree, so that means the sibling from which we get a value, okay, so that sibling contains more than the required minimum number of keys. For example, so in this this sibling contains 3 keys. So previously before swapping, this also contains 3 keys. Okay, so if I get a key from this particular sibling, so after swapping this sibling, the number of keys in the sibling will be reduced to 2. So here the same thing, if I select a key from the right sibling for swapping, so after swapping for this also, it will, the number of keys will be 2. So after swapping, the minimum required number of keys in all the nodes, that particular property will be satisfied. Suppose, for example, so now consider, just for understanding, I just delete this 36. So this is the current B tree. Suppose if this is the B tree, and then from this B tree, if you need to delete a key, that is 60. So I'm going to delete a key 60 from this B tree. So as usual, from the root node I just search for the key 60 and then I reach that node where the 60 is present, and this is a leaf node. And I check whether that leaf node contains more than m by 2 minus 1 keys. No, it just exactly contains exactly m by 2 minus 1 keys. So we cannot simply delete that key, so we need to swap a key from the any of the sibling. Okay, so and then I go and try to get a key from left sibling. So suppose if I select the maximum value 30 and I am going to replace the deleted key with the 30. If I swap that 30, suppose if I swap that 30 means now the number of, after that swapping, the number of keys in the left sibling will become 1. So that violate the minimum number of key constraint. So in this case I cannot swap a value from the left sibling. So I will go and try to replace the key from the right sibling. So in this case I need to select the maximum value 66 for swapping. So if I remove this 66 from the right sibling, so after swapping, so here also the number of keys, the number of remaining key will be 1. So that also violate the minimum required number of key. So this is also not possible. So this is another case 3. So case 3 means the node contains the node where the key to be deleted contains exactly m by 2 minus 1 keys, as well as both of its sibling also contain exactly m by 2 minus 1 keys. So in this situation, how the key can be deleted? So we will see that in the next video. So in this video I just explain the deletion operation in B tree. So there are at the top level there are two cases. First one is deleting a node from leaf node, so deleting a key from leaf node and deleting a key from the internal node. So in this video I am just explaining deleting a key from a leaf node. So in this case also there are three different cases. First one is deleting a key from a leaf node that contains more than m by 2 minus 1 keys. So and then case 2 is deleting a key from your node that exactly contains m by 2 minus 1 keys. So in the first case, more than n by 2 minus 1 keys, just we delete that key and there is no need to any swapping or any updation. So in the second cases, that particular case can be solved by using two approach. So in both approaches, what I am doing means I am going to get a value from either of its sibling and then I will do some kind of swapping. So if it is left sibling means if I select left sibling, then I need to select a maximum value from the left sibling, and then I swap that maximum value of the left sibling with the minimum value of the separator in the parent, and then the minimum value of the separator will be placed in the will be replaced with the deleted node. So if you select a value from the right sibling, we need to select a maximum value from the right sibling and we need to swap that maximum value with the maximum separator in the parent, and that maximum separator will be replaced with the deleted key. And the third key is if both the sibling also contains only m by 2 minus 1 case. So in this case swapping will not work. And how to delete? So in that particular situation, how we can able to perform the delete operation, we will see it in the next video. Thank you.